Good? All right. So, a line and a parabola. Okay? We're supposed to do substitution here. Again, most of you are not going to do substitution because you have a calculator. So, this is what we did yesterday. This should all be reviewed. So, those of you that weren't here yesterday, here it is. Okay, so the first equation, before I can put it into the calculator, what do I have to do? Make it y equals. So, what's my first step? Add 4x first. I've got to add 4x to both sides first. So I get 2y equals 4x plus 8. Now I have to divide it by 2. Everything gets divided by 2. So we finish off with y equals 2x plus 4. Okay, now both equations are set equal to y, so we can now plug it into your calculator. Okay, so we've got 2x plus 4, and we've got x squared minus 6x plus 11. And we graph. There's your linear function. There is your parabola. What's the problem? Bless you. What's the problem with this one?
We can't see both the intersections.
You can't see both intersections. So Jeremiah, how do we need to adjust it?
We need to go to window.
Okay. What are we adjusting?
I think we should adjust our Y max.
I agree. We're going to adjust our Y max. I need to see higher so I can see that intersection on the right. What do we want to change it to? We are not adjusting it to 587,000, Elijah. 25. Graph. There's your line. There's your parabola. It worked. Yay. Okay. How do I find an intersection? Second trace. Choice number 5. Okay. Go as close to the intersection that you want to try to find. And you just hit enter, enter, enter. So your first solution is at 1,6. Okay. I need to repeat all steps to do the second solution. So second trace. Choice number 5. I need to scroll way up to this intersection. Okay, enter, 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 and you said 7,18. Does anybody know how to get the answers from a table?
You want to learn.
You want to learn? If you hit second graph, here's your table. Whoa, hold on. Go to your table set first if it's not already set and set it at 0. Sorry. Clear that out and set it at 0. So if you go to second window and go to table set, because we were doing some funky stuff in discrete.
I thought you said a bad word.
Funky. Funky.
Oh.
Okay. Take a look when x equals 1. Look at both of your y's. They're the same. That's from the table how you know. If you scroll down, the other one was 7,18. So if you scroll down to when x is 7, when your y's match, that's the solution. That's an intercept. Okay, so you can also get it from a table. The only time you can't get it from the table is when it's a decimal and it's not pretty whole numbers. Okay, so you've got both options. Okay, let's go to the other side.
Why would I ever use the graph again?
If they're not perfect answers, so like if it was like 2.5, 4.2, it's not going to show up on your table. Okay, Rebecca says we have a problem. The first one is negative y. So I need to divide everything by negative 1. So that makes it y, negative 4x, and positive 9. Remember, when you divide everything by negative 1, all it does is change the sign. Yes. Can you see the stapler again? Yeah, it's over there. You're welcome to get up.
I thought you had it with you.
No, I don't. It's over there. Okay, so you want to go back in your y equals and plug in these ones now. So negative 4x minus 9. Oh, I'm sorry, plus 9. You're right. Thank you. Negative 4x plus 9. Make sure you put in negative and not the minus sign, or else it will not graph it. Okay, 2x squared plus x plus 12. And we hit graph. So there's your line. There's your parabola. Parabola?
I don't see my parabola.
You don't see your parabola?
I don't get one.
Windows 25.
Change your y max to 25. I didn't change my graph back. I didn't clear out my calculator. That's why you can see it still. Okay, so we need to figure out how many times this actually intersects. Okay. It looks like 1. Let's try to zoom and see what happens. Let's zoom in. Do choice number 2. So if you go to zoom and choice number 2 is zoom in. Okay. We want to zoom in close to where it looks like it's intersecting. So if you move that little cursor close to the intersection and hit enter, it should zoom in on it here for us.
Whoa.
Whoa.
Kind of looks like 2.
So it kind of looks like 2. Okay.
A lot more than 2.
So what we're going to do is we're going to go to second trace and do choice number 5. Okay. Because it looks like we've got 2, it looks like we have one closer up to the left and one farther down to the right. So move the cursor farther up to the left and hit enter, enter, enter. It will move it to where the actual intersection is. So we do have 1 at negative 1.5 and 15.
How do you do the zoom?
You want to hit zoom and choice number 2 to zoom in. Okay, when you do that, it'll bring up a little cursor. So I need to turn on the light so you can see your. So some of you can see your calculators. Sorry, it's hard to see the calculator sometimes in the dark. Okay, so it'll bring up this little cursor thing. You want to get it like as close to the intersection as you can, so it'll zoom in on the intersection.
I'm rude.
And now you can kind of see that. Okay, so second calculate or second trace. Okay, so we have 1 at negative 5 comma 15. That's the one closer to the left. Yes, Kate.
But if you go on the table, there's only 1.
But if you zoom in,
Because it's not going to show you the decimal.
you zoom
Because
in
this
far,
one's a decimal, it's not going to show you. Okay, so if I go back to second trace, and again, intersection. We think there's one closer to the right, which Brandon's already said. Yes, there is. I promise you. Okay, so move your cursor farther to the right on your graph. So I'm kind of closer to the bottom of that parabola. Okay, and hit enter, enter, enter. So there actually is another one. Is that the one you got from the table, Kate? Negative 1 comma 13.
Yeah.
Okay, again. It didn't show that first one on the table because it's a decimal. It's not a whole number. It's not going to give you the whole number or the decimals from the table, which is why the table's a good thing, but in a way it's a bad thing because if you have one that doesn't fall perfectly on a 1 comma 2, okay, whole numbers, it's not going to give it to you. Questions? Okay. If you flip that page, we're still dealing with linear and quadratic. So I think we're going to skip that one for now. Okay, we just did 2. Skip that one for now. Okay, so we're going to skip. Now we're doing quadratic systems of equations. Quadratic systems. Okay, so I've got 2 quadratics. So when I grab these ones, it's going to look like what? 2 quadratics. 2 parabolas. No more lines. Parabolas only. Okay? So the first one is good already. The first one should be good already. Second plus 712, clear out your calculator. Because we've zoomed and everything else.
Did you skip 2?
Yes. Because it's the same thing that we just did in number 1.
What was the answer to the second one? The first one?
I can't get it off of somebody else. Elijah, put back to your first spot and get the answer to that second one. Never mind. Kinsey's got me. Okay, the first one.
It only crosses the one.
Okay. Rebecca says it only crosses once. Okay, this one's already set equal to y, so you can go directly into your y equals. Okay, so we're typing in x squared minus 7, and we're typing in x squared minus 6x plus 11. Parabola? Parabola.
It's 32.
Okay, hold on. So, Rebecca, while you can only see one on here, there are actually 2. Because this second parabola that it drew on the right, what it's going to happen is it's going to keep going up and up and up. It's going to reach it somewhere up here.
But they look kind of parallel even when you zoom out. It's still, yeah, because it's x squared for both of them.
Hold on, let's check it out. So let's go to our window. What did you take yours to, Jeremiah?
I went to 100 right there, but I'm going to 1,000.
You're going to 1,000? Oh my goodness. All right, let's see. Whoa,
Yeah,
that one got,
never touch.
they never touch. Okay. That's something you should check though.
I was right.
You were right.
Good job. Good job.
So let me go back and fix that. 10 graph. Okay, so we've got one intersection. He says, ah, ha, 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 ha. Okay, one intersection. Somebody get it for me. 3, 2? 3, 2. Enter, enter, enter. It crosses at 3, 2. Okay. Meow. Uh-oh.
Exactly, that's what I said.
Woo! It's really not. Okay, let's handle the top one first.
Oh my
What's the first thing I have to move?
You're gonna have to subtract
We're going to have to subtract that 1. If I subtract the 1, what does it go with on the right? The 9. Remember, like terms, you've got to keep them together. So we now have negative y equals x squared plus 3x minus 10. We've got a negative y, which is a no-no. We need to make it positive, which means everything else, divide by negative 1. So now I have negative x squared, negative 3x, and positive 10. The second one, what do you need to do first? Whoa. Add your x. Okay, we need to add your x. What does it go with? The 5x. So we have 2y equals 2x squared plus 6x now plus 4. My last step is to divide everything by 2. So Elijah said x squared plus 3x plus 2. Okay. Rebecca says, I've already graphed it. There's 2 intersections. So again, if you go to y equals, my first equation was negative x squared minus 3x plus 10. I did copy the right equation, right?
Yeah.
Okay. Please double check me. You know how I am. X squared plus 3x plus 2 for the second one. And we hit graph. Woo! Upside down. What made that one go upside down? The negative x squared. Woo! Okay, so we do have 2 solutions on this one. If I calculate an intersection, Whoops. I totally just hit the wrong button. A second, calculate. Choice number 5, enter, enter, enter. So we got -4, 6. You said 1 and 6? So -4 and 6, 1 and 6. Okay, so we're pretty good with systems of linear, quadratic, quadratic, quadratic. Today, we need to take it one step farther. Instead of doing equations, we're now going to do inequalities. What does that mean? Greater than, less than. So you've got solid lines and dashed or dotted lines. And what else do we have to do? Shade. Okay. Can I just tell you this? Your calculator shades for you.
What?
Yeah.
Yay! Okay. So, flip to your last page. Okay, we're going to systems of quadratic inequality. Do I want to hear something?
Yeah.
Sure.
Okay. So we go to school. I wasn't there. I was in New York for my grandma was feeling well. So my math teacher at the time, I came back and they were learning this, and I asked her what we were learning, and she never teaches me it. So now I don't know what to do. Pop me.
Okay. So, yes.
Yeah, let's do it.
I didn't
Where you're at.
know that. I was actually pretty good.
That's why you didn't have X squared there at the beginning. All right. So, okay, in your calculator, I want you to go ahead and put both of your equations. So go into y equals, clear everything out, put in these first two equations. So we've got x squared minus 3x minus 4. We're in the last flap if you have not turned completely on the last page. We skipped the next one. We're on the last one. Okay, we're on the last page. So there's your first equation. Negative 0.5 x squared plus 6. Okay, now I want you to scroll up. Okay, so get your little flashy piece right there on top of x squared. And then I want you to press to the left. It takes you to the equal sign. Go to the left one more time. It takes you to side y1. Okay. What is this symbol if it's an arrow pointing to the right? Greater than. That is your greater than symbol. So normally you would shade up, greater. Numbers are greater up or to the right. Okay, so you need to tell your calculator where to shade. So if you hit enter, okay, that takes your line and it makes it thicker. Okay, if you hit enter again, look where it's shaded. That's shaded up. So that's your greater than. That's your greater than. Okay, move down to the next one. This one is what? Less than. So again, if you hit enter, there's your darker line. If you hit enter, that's shading up. If you hit enter again, that's shading down. So, okay. So Elijah said that one's less than or equal to. All you need to know with that is your first equation should be a dashed or dotted line. It's not equal to. Your calculator will not do that.
That looks weird.
Okay, just know that it's a dashed or equal or dotted line. Okay, your second equation is less than or equal to, which means it just makes your line thicker on the graph. So instead of having it just a thin line, it's wider.
For blind people.
It's kind of more like a bold. Okay, so if you hit graph, here's your first equation. Here's your second equation. There is some voodoo going on here.
Oh my God.
Right, I don't like it.
Because you didn't put an X here, you put squared instead of X squared. Okay, so that first squared to an X. Huh?
That's I can't wait to take his class next week.
Good, you'll be fixing my calculators a lot.
Mr. Bless.
Okay,
Everybody I talk to.
so because there's not one actual solution to this, we are actually going to have to graph these ones.
No.
Okay, you're not going to have to graph it on your test. It's going to give you multiple choice answers. But for our purposes, we're going to have to graph these ones. So what I want you, I can wait. Because you do have homework tonight and you're wasting time. So that works for me.
Sorry.
Oh, no, you're fine. I'm just waiting for silence before I continue. So let's make it easy when we go to graph this. Go to second table. Okay. So your first equation, okay, you're using X and Y1. So we have a point at 0, -4. Okay. 0, -4. 1, 2, 3, 4. I have a point at 1, -6. I have a point at 2, -6. A point at 3, -4. A point at 4, 0. Okay, just give yourself a couple of points so you can then graph your picture. Okay, so remember, this is greater than, so this should be a dotted line. So we're going to dot it as I draw it. Here's your parabola. It goes up. Okay, there's your first one. Okay, you're going to do the same thing with your second one, but now I'm looking at X and Y2. So I have a point at 0, 6. 1, 2, 3, 4, 5, 6. I have a point at 1, 5.5. I have a point at 2, 4. I have a point at 3, 1.5. Okay, this one's a solid line. So here's this picture. So there's that picture. Okay. It's not going to be absolutely perfect. So again, I got my points from here. Okay, your first equation is X and Y1 together. Your second equation is X and Y2 together. Okay, now if you go to your graph, look how it was shaded. So my first equation gets shaded up. My second equation gets shaded down. Okay. Any points that lie in that double shaded region are solutions. It must be in the double shaded region. So if you only have one color, my suggestion to you is one equation shade lines up and down, and your other one shade lines left and right, so you can see the crossover. Okay, it's easier to see the crossover that way. If you've got two colors, rock yourself some two colors. Okay. All right, listen. So what I'm going to do is we're going to do one more together. The last two are going to be your homework. Okay. All you got to do is plug it into your calculator, get some points, graph it. Okay. All right. So this second one, these are already equal to y, so we're good to go. So again, go into your y equals. Clear it out. Notice when you cleared it out, it also cleared your shading. So you're going to have to go back and change that too. So my first one is greater than. So you need to change your shading to be greater than. So that should be the one shaded. Oops, I went too far. Okay, I went too far. So shade up. And then you want to type in x squared minus 8. The next one, I want to shade down. And this one is just going to be x squared. So let's see what this looks like. Whoa.
What the?
Okay.
Oh. That one has a parabola inside of where your original one was.
Then why's the rest of it shaded?
They're both
Because that shades down. So what you have right now is you have a graph that looks like this, and it's shaded up. And then you've got a graph on the inside like this, and it's shaded down.
Oh.
Infinite solution.
So that's what that did.
I could say.
So right here in that double shaded region, right here is where your solutions lie. Okay. So that's what that's done. So again, if we go to your table, you've got a point at 0, negative 8. 1, 5, 6, 7, 8. I've got one at 1, negative 7. 2, negative 4. 1, 2, 3, 4. Okay. Because I know it curves to the right or to the left, I can go up farther and get some other points. Okay. I can go to the negative side and get some points. So I've got one at negative 1, 7 and negative 2, negative 4. Okay. This one is equal to, so it should be a solid line. Okay. Once you graph this one, it's greater than. This one shaded up the inside of it. When I go to the other side, we're at negative 2, positive 4. 2, 3, 4. So here's that point. Negative 1, positive 1. 0, 0. 1, 1. 2, 4. This one should be a dotted line. Notice it's on the inside of what you just drew. This one is less than, so it gets shaded at the bottom of the parabola. So that's all of this. Okay, so that little piece in between the two parabolas is where all of your solutions lie.
That sure is.
Okay, so they may give you a picture like this and say, the point 0, negative 2, is it a solution? So if you would go to 0, negative 2, that's right here. Is it in the double shaded region? Yes. Therefore, it is a solution. Okay. Yes, ma'am.
I've been trying to get your attention, but you just been like.
Because you're asking me questions ahead of what I'm trying to teach.
I haven't asked any questions.
I could hear you back there. Do I shade this up or down?
I was
heard
talking
you.
about the last, when you, before you were to move on, I was talking about the y equals part. Did you put up on, did you?
To put it in the calculator?
You was already shaded on the paper when I asked that.
Okay. Yes, you need to go off of your inequalities. So if it's pointing to the right, it's pointing to the higher numbers, so it's greater than. If it's pointing to the left, it's pointing to the smaller numbers, so it's less than. Okay, so this first one gets shaded up. The second one gets shaded down. Any other questions? Yes.
If it has a greater sign or equal to it, it's a
Solid line.
Solid
Yes. Okay. If we need to make that reference too. Oh, actually, let's go up and fill up this top part because I missed that. I'm sorry. Okay. Less than or greater than without the equal sign is a dotted line. With the equal sign, it should be a solid. If it's less than, we shade down. And if it's greater than, we shade up. If the two shaded areas do not overlap at all, the inequality has no solution. Okay. So again, you have 2 problems to do for homework. That's it.
The last two?
Yes, the last 2. This glues in on page 68 in your notebook. Okay.